Welcome back to Venture Wisdom. Welcome to the place we talk all things venture capital and private equity. And today we are here to discuss a different part of the buzzword called AI, right? So AI is a household term as we talk today. But then there are too many sides of AI. And what we are covering today is the opportunities for investment in physical AI. To discuss that, joining me, we have Jasmeet Singh. Jasmeet Singh is an engineer turned builder turned entrepreneur turned investor. He's based between Silicon Valley and Toronto, has been in the field of physical AI for over 20 years, has invested in over 2 dozen of the physical AI robotics slash related companies, and right now is in process of building his VC firm. He's popularly known as Bearded Maker across all his social handles. So if you have to look up for Jasmeet, look up for Bearded Maker and you'll find it. But then, Jasmeet, thank you so much for taking time for joining me today for this conversation.
Absolutely, anytime for you. That was a great introduction and very, very accurate. With one change, I people usually don't know this, but I started investing before I founded my companies. So
Interesting.
what? Yeah, so I had my I just graduated from my master's, and I had some money, saved up, and I was very passionate about humanoids. So the one thing I did was just invest the money, majority of it, and with what was left over, I started my company.
And you're talking about the times when humanoids was still a fiction.
This was 2012, yes. So
Yeah.
there were not a lot of humanoid companies to invest in, maybe two, I think. And within a year, I had invested in the third, but yeah. So whatever was happening in the world of humanoid at that time, I kind of invested in.
Interesting. So yeah, no, I know that for all those reasons, you are the right guy to speak about our subject today. But before we get into the conversation, tell me, is it real that you built a Iron Man or 3D printed an Iron Man costume for yourself?
Right, yes. So it took me about 2 years of planning. And because I didn't have time to actually work on it, like I was like testing things out. I was running my companies at the time, barely had time, to work. I think I started planning it in 2018. And in 2020, when the lockdowns hit, I was like, this is perfect timing. I have less work to do, and I have time to actually finish this costume. So 2 years of planning, 6 months of printing, and sitting down and sanding everything. So it's fully 3D printed, multiple materials, all the electronics is like totally distributed. There's no wires going from one piece to the other, and you can basically disassemble it and take it part by part. So yeah, it took a long time, and I had to learn how to paint cars essentially. So it's the
Hmm.
same way that you paint cars, the airbrushing technique, same technique gets used on that suit. So that took a while just to learn that technique.
And did we have
Uh,
Jarvis in it as well?
I didn't install Java. I didn't have enough time to install Javas. I could have. Like, it's not a difficult thing to install. I focused more on the effects of it. So, for example, this particular suit was Mark 50. So, in Mark 50, it doesn't lift the faceplate. You can take the faceplate off. So, the moment you take it off, the light turns off. The moment you put it on, the light automatically turns on in the eyes. So, those kind of effects were some of the things that I kind of worked on. Yeah, very, very laborious process. Spent, I don't know, like the 6 months that I worked on it, it was countless hours. Just,
And is it custom built to your
oh
body
yeah,
size and shape? I cannot try it.
yeah. It's custom built for me. It's built so I can insert myself into the suit. It's built so it's a little bit taller and a little bit wider than I am, but so only to make sure that I can fit myself into the suit.
Damn. So you
Uh,
have to build another one for me in that case.
yes, I would have to. I would definitely have to. But yeah, it can
Yeah,
be done.
I know. I would be too interested to try it on, but yeah, at least to see you in it someday when we get that opportunity.
Absolutely.
But Jasmeet, I know that you have spent almost 20 odd years in this space,
Mm.
which has certainly evolved in last few years, right? So
Mm.
while the term robotics has been there forever, hardware has been there forever. AI has been heard for almost 20 odd years now, 20, 25 years. But the applications of AI are evolving and more so into the physical AI as we speak. So let's
Mm.
start from the audience point of view to understand what exactly physical AI means.
So let's clarify what AI is first. So there's a lot of pieces of AI. The current piece we have is LLMs and large map models, but that's not always AI. I mean, there are other aspects to AI. We've had NLP for a long period of time. We've had self-driving features for a long period of time. We've kind of known how to do self-driving. The sensors needed catching up, but algorithms were already there. Like I said, during my master's, humanoids, self-driving, and computer vision was some of the things that I was working on. So that's been there for a long time, right? So in robotics, AI is inevitable. You can't go without it. You have to have the hardware, and you also have to have the capability of bits and pieces of AI going within robotics, because without it, there's no interfacing, there's no control, there's no autonomous features within robotics, right? So physical AI is a term borrowed from academia, and the way it's defined as is AI moving in the real physical world, essentially. And the
Mhm.
way to do that is, or interacting with it, sensing environment, acting on whatever the judgment is being made. And that piece, it involves hardware plus AI. So you can't have one or the other. Hardware, hard tech can exist on its own. There's medical devices, electromechanical stuff. You can have that stuff without the AI piece. You don't always need AI. You can just have maybe some software if you need to, but doesn't need AI. And then AI can potentially not exist without hardware. I mean, there's you need the cloud computing, you need the GPU, but that's not really moving in the environment. It's still on the in the cloud. But if the AI is able to sense the real world environmental data, it's able to act on it, draw inferences and then act on it and figure out what the next move might be. That's what physical AI is. So that comes in various forms. I usually focus on three or four, which is robotics, IoT, XR devices, so augmented reality, virtual reality devices, and wearables. Those are
Sure.
the four sectors that are going to be truly, important in the next, I would say, next 5-10 years.
But between all these as well, whether robotics or the XR, VR, or the other spaces that you said, again there's a fairly wide variety of use cases slash areas where you see the implementation between
Mhm.
domestic to industrial to transport to all these different places. What are the top few applications that you see in real world today that are happening from the physical AI point of view? Because
So the,
I know that you just mentioned that hard tech and hardware can exist by itself, and it
yeah,
has been there forever, right?
yeah.
And I know that even in medicine or health tech, where AI is coming along with the hardware quite a lot,
Mm-hmm.
there have been applications with the robotics as a
Mm-hmm.
surgery, medium to surgery for a while, right?
Yeah.
But with all the remote surgery coming in and evolving with the use of AI is one thing that I can think of. Just from the viewer point of view, I'm quoting an
Mm-hmm.
example. But what are the things that you are seeing and you are betting on as we speak today, which are live? We'll come to future in a while,
Mm.
but I'm very keen to see what we are seeing in the real life today.
Right. So let's talk a little bit about the past first. So robotic arms have been around for years. We've pretty much built the whole auto industry runs on with robotics arms, right? It gets assembled, and software controls those arms. And the thing with that part of robotics is that it's built by engineers for engineers. So the interfaces, the way that it functions, the way that it's controlled is built so that engineers can use it. Engineers built it and engineers can use it. The good part about what we've seen in the last few years with AI, LLMs, and large models coming out is that now you have an interface that anybody can use, right? So now you can tell your robot and say, pick up the red ball on the table without specifying the location of the red ball. If it's a robotic arm, you could just say, like, pick up the tiniest of things without specifying where it is, without specifying what, the hardness of that object is, without specifying what the shape of that object is specifically. And it'll go and pick it up because it recognizes that particular thing that you've just mentioned. So that interface has improved. So when you, even in the industrial side, what's going to start coming up next, which we're seeing right now, is that application of improvement of the interface of the traditional industrial side. So for example, there's a company called Orangewood I invested in, based there in this valley, and also they have operations in India and UK. They build robotic arms, and they're a 𝗕𝗍 startup, right? And they are working on something that allows users to just talk to the arm itself, just in a normal language. Anybody can do it in any language. So that's the beauty of
So
that.
in this case, the use of AI is more towards the natural language interface with the robotic arms, or is it the spatial understanding of the robotic arms to pick things which are being spoken about?
It's both. It's both. In this particular application, it's both. It recognizes where the object it understands, the LLM part understands, what that language is actually trying to say, and then breaks it down into actions, breaks it down into path to take, breaks it down into where to go, from which direction, where it is right now to the goal destination. And so it breaks that down into just multiple tasks. So those are the kind of things that people are working on, and that will improve the industrial side of it, so that anybody could use that interface if they needed to. So it doesn't have to be just that, engineer person coming in and, controlling it a certain way. The second thing that helps with that kind of an interface is safety. So it improves safety. And we had some cobots in the past, I would say 10 years ago, 2014, approximately 2016. Around that time, there were a lot of cobot companies coming out, because that was a big issue. People started noticing safety was an issue. So one of the things we've done is build, better sensors to detect if there's a human nearby, and if there's a slight friction in the robot being able to execute its motion, it knows that there's something there blocking me, and I should probably stop instead of, keep going, instead of forcing my way through. So those kind of sensors and actuators have been developed specifically for that reason. So that's a great combination. That's just on the industrial side of it. Then another thing that's happening on the industrial side is the new thing that nobody thought was going to happen, which is humanoids. Humanoids, right now, people are not ready for it. But on the industrial side, the good thing is that it works in a closed environment, and you can figure out it's a controlled environment, and you know what exactly might happen, and there's limited use cases. So humanoids are perfect for that application if you want to replace humans for whatever reason, or you want to add to the workforce because you have low workforce and you want to add more humans, which is not possible. So you just add humanoids to replace some of those tasks. And that's the biggest application of humanoids at the moment in the B2B side. And I think that sector is set to grow like 15x in the next 5-10 years. But yeah, so that's one of the applications, of that interface, of being able to tell a humanoid, like, hey, this is where you go, this is the task that needs to be done, and breaking it down into simpler tasks. Another sector we are seeing is autonomous checkout stores, and that technology is usually limited to bigger stores. But another company I invested in, Brisk, they're doing that for smaller stores, right? So any mom and pop shop could potentially have autonomous checkout technology. So if you are going into a coffee shop and you want a bagel and there's a line forming, you don't have to wait in line for a bagel, right? You just grab the coffee, you might have to customize, but to just grab a bagel in the morning, you don't have to wait in line. So you just go in, pay, and get out. So those kind of applications we are already starting to see deployed. I think robotics and IoT combination will come in first. The applications of
Mostly industrial, you're saying?
Yeah. So I think the reason of that is for smaller wearables and XR devices, the thing is that you need better battery. You need something that heat dissipates heat properly. So you need something that can handle AI on the edge. So the computing power needs to be there. So those might take a little bit time, not too much, but a little bit time. While robotics has, we already have bigger batteries we can deploy in robotics. So we can make it autonomous, but also connect it to wires and not an issue. IoT also in houses and most places, you have a wired connection to IoT devices. So I think those applications come first. And while they're increasing, the smaller applications, as we increase and improve the compute, I think the other applications are going to start coming in soon.
So two interesting things here. One, a recent development that happened in the market. But before getting to that, the point that you brought in about the importance of the edge computing / edge based AI in terms of robotic. Where do we see that? Because the now connecting to the other point that I was saying, we recently heard Alphabet announcing the Gemini robotics, right?
Mm-hmm.
So I just trying to connect the dots there with the Gemini robotics, with the edge AI, with the industrial robotics that we are talking about today. What do you
Right.
see happening there?
So the reason that that is happening is, if you look, even if you look at OpenAI, they started off as a robotics company. Like their research was all robotics. They were doing a bunch of stuff with robotic hands. They were doing a lot of stuff with like manipulating Rubik's cubes and AI, and then they pivoted and launched
But here
Chat.
it's the other way around, right? So Gemini started on the other side, but
Yeah.
getting into the robotics now.
Exactly. So the reason for that, and now OpenAI has also launched their robotics division again. The reason for that is because all of these companies are working towards AGI, right? Artificial general intelligence. So how do you get to general intelligence is the problem. The only way to do that is to make the AI move into the real world. There's a lot of data in the real world that you can't learn from the internet. There's a lot of data in the real world that you can't learn from books. There's a lot of data that you can't prompt people to understand, make the AI understand. For example, let's say you can describe, if I asked you to describe grass to an AI or a robot, how would you do that? Right? There's you'll say, well, it's green and the leaves looks like this, or the computer vision is able to detect that the leaf looks like this, and that may be that it's grass. And if it's on the ground and it's flat, it's likely grass that you're going on. But how do you explain the texture of grass? How do you explain what happens when the grass is wet and that it might be slippery, and how the robot needs to control itself when that happens? Does the robot have legs? Does the robot have wheels? And how those wheels the friction might change for those two when it's going on grass. So those kind of things are impossible to explain to AI in like outright by anybody. And that has to be learned behavior for the AI. So that's the only way you get into unstructured environments, something that's, a little chaotic. You have no idea what is going to happen next. And so that's what AGI is supposed to do. So that's why a lot of these companies are moving towards, some robotics initiatives, because they realize that the AI needs to do that. Physical AI has to be the foundation that we work on right now to get to AGI.
And how much of it is still cloud versus edge?
Most of it is cloud at the moment, right? You can scale it on the cloud. It's much easier to do that, which is awesome. For even for robotics, it's very great that we can do that. You can control a fleet of robots using cloud and have it run AI and have each of those robots learning from each other using that method. So that's great. But at the edge, it needs to learn some of the behavior, but then you can abstract it a little bit and give the rest of the learning to the cloud. So for example, if you have robots in somebody's house, you have thousands of robots in people's houses. You don't want to learn what their individual schedules look like. What you want to learn is overall user behavior. How are people interacting with the robot? So individual user behavior stays on the edge, while the bigger abstraction stuff can go onto the cloud and get learned from there. So that's one other thing. Another issue is, you've realized we've seen AI that can learn from watching videos on the internet, and that's currently being done. You teach it to perform a task when it's learning from the internet. Now it can It's watched a few, YouTube videos and it learns how to make coffee, for example. But what use is that if it can't actually make you the coffee? If it can't actually go into the kitchen and make your coffee, what use is that AI? So that's where physical AI sort of comes in, and why it's important if we need to get to AGI.
Sure. And having said that, what are those top five odd use cases? It can be three, it can be seven. Just mentioning that we see live today. So we just spoke about the robotic arm. We spoke about the industrial side of it. But what are the top use cases that you see? I know that there's a lot of work that is happening on the healthcare. There's a work that's happening in agri. That's probably happening in retail and other places as well.
Yeah.
But then keen to hear your point of view on that.
So there's a few things that are coming up right now because we have the capability to do them. Robotics in public spaces. Like if you want agriculture robots, if you want robots in retail spaces, if you want, robots in restaurants, we have those capabilities.
And then we have been lately seeing a lot of action in the supply chain, deliveries, and warehousing side as well. I think you spoke about warehousing already, but we see a lot more because why I'm bringing this up, because this is kind of a mix of industrial / domestic, because deliveries are out on the road. Right?
Yeah.
So how much action is there and how reliable it is already?
So deliveries, you're absolutely right. Logistics is always a problem. We've been working on it for a long time. Warehouse robots, I think the first one that I worked with was I worked as an intern for 𝗓𝗄𝗧 in 2011. It had just launched at that point of time. And that's a great warehousing robotics company. There's still challenges there that can be fixed. There's still human in the loop, and which should be there. But I think the aim is to have totally remove that human in the loop if we can. Just because it's a high risk environment. Sometimes if a shelf falls down on somebody, it's a high risk environment. So I think that's why we want to remove that. But it's at some cases there's always going to be some kind of a human in the loop there. In terms of delivery, I think there's a lot of companies coming out right now. Some cities are also taking initiative to actually run those pilots. I think Toronto is doing one, and in SF and other places you can usually see a bunch of delivery robots. Each has their own sort of business model and use case that they've created depending on the size. If it's a smaller one, you can do last mile delivery. If it's a slightly bigger one, you can carry packages from one place to another. If it's the size of a car, you can make it deliver from warehouse to warehouse. So there's a multiple application. If it's a truck, again, then you're going cross cities. So that autonomous driving feature in logistics it's possible now. The only limitation there is government regulations. What is allowed and what is not allowed. In terms of technology, there's no limitations there anymore. We have the sensors, we have the actuators, we have the AI capabilities. If we wanted to, we can put humans in the background who are able to observe, through telepresence that whatever is happening, it should be happening. And if something gets stuck, it can, avoid the obstacles. But majority of that, even then, there's a bunch of companies who are working on improving that. What happens if a robot gets stuck? If it's totally autonomous, the other one comes and pushes it out of the way, and it realizes, or we can send it there. So there's a bunch of these applications that always have to exist.
From use cases, switching the gears to the investment side of it, right? And if we typically see the model that the VCs follow, and why I'm saying VCs here and not the private equity or the other investors, is because the industry is still probably at the early stage, right? And that's where the VCs come in most. But if you look at the VC as a business model, from the investment point of view, the bent has always been towards asset light, high margin businesses, which is very counterintuitive to what the robotics industry sound like to a normal person. So how do you see the business models in the physical AI evolving, which make them attractive to the investors?
So another issue in that VC industry is when it comes to hardware, there's way too many business models. And hardware is, like I said, even if you take those 4 categories of robotics, IoT, XR, and wearables, there's way too many different business models depending on the applications. Is it B2B? Is it B2C? Is it for entertainment? Is it for a future of work? Is it for on the customer facing side or user facing side, or where exactly is it fitting in that environment? So there's way too many use cases, and some VCs try to narrow that down, by investing in particular sector of robotics, by saying, well, we only invest in the software side of robotics. And that's been happening for, I would say, the last 3-4 years, because software and AI is increasing. So they're focusing on that part of robotics, because again, it's still asset light. It's not as capital intensive. You can, if you have been investing in software and AI, you can kind of translate that to the robotic software experience. The way I see it is, hardware has not seen traditionally a lot of capital early on. That's the main problem. So a lot of angels have existed in this space, which is amazing. Exited founders, angels who've had, a commercial experience or industry experience. These people have kind of pushed the limit on early stage investment, but there is a gap for the VC market. By late stage, by Series A, the expectation from a hardware company is much more than a software company. You're no longer allowed to pivot, right? You have to have
because it's expensive. You cannot do
it's
that.
expensive. You can't do it. Like, it's impossible to do it. So the expectation by Series A is that you can't pivot. You have your customers figured out. You have your tech figured out. Obviously, you have your business figured out from the moment the idea and manufacturing goes from your desktop design to actual manufacturing, and the logistics, everything needs to be figured out before you can get to even Series A. And at Series A, then you can start to get growth capital, and pretty much anybody can invest, because at that point of time, it's just a business. It's just numbers at that point of time. You can look at
much
it
safer as well.
Yeah, so it's much safer at that point. So Series A onwards, there's a lot of investors. There's a lot of CVCs. There's a lot of bigger investors who can
But
invest.
until Series A, in fact, including Series A, for that matter, what I have been observing sitting in the market is that there's a huge gap of those risk takers yet, particularly in the market that we are talking about today.
Oh yeah. So pre-seed doesn't exist. So
Yeah,
it's
pre-seed does
angels.
not exist. It's either those angels, as you are saying, who
Yeah.
have experienced that market, who have a sense
Yeah.
of that market, or probably a little later, it's the strategics which are coming in, who are doing their innovation programs, accelerator programs, so that something could be plugged it back into their businesses.
Exactly. So the thing with incubators, accelerators, venture studios is that at some point their support ends, and then the founder is usually left to figure out the rest of the stuff by themselves. Because in the real world, you can't stay in that accelerator program forever, right? So it takes a while for founders who are coming from a totally tech background to learn that kind of thing, how to pivot to the business side, or how to learn the business side of it. Because there's experiments that they need to perform on the business planning. They have no idea how the logistics is going to work. They have to figure out the right manufacturer who will not steal their IP, who can be trusted for a long period of time and can scale with their operation. So going from like 10 pieces to 10,000 to 1,000,000 pieces when they need to scale. Because once you lock in a manufacturer, you usually don't want to change it, because quality controls have already been set. You kind of have a long-term relationship going there. So those things take a lot of time to figure out, right? So which is why this early stage capital usually doesn't exist in the VC ecosystem for hardware, because it's not even just the fact that it's capital intensive. Like, if you look at the life of a software company and the life of a hardware company, they raise about the same from VCs. So it's not VC capital that's going in. The rest of the capital that these hardware company need, it's coming from revenues, because they're early revenue generating, because they have to be, because they don't have the VC funding early on. So they're revenue generating early on. There's government programs. You can get grants. You can get additional help from government in R&D credits. So there's initiatives out there from the government that allow them to do that. But those grants come with stipulations. So you're limited in what you can do. How you can scale it, or what your mandates the government is providing. So that money, but you can get loans if it's asset backed. majority of them are, you can get actually loans from the bank. So there's non-dilutive capital that can come into these that is typically not available to software, right?
So that's that what you bring a very interesting point here, Jasmeet. So the gap of that early stage capital that is there,
Mm-hmm.
right? And for whatever reasons stated right now, my my curiosity brings a question that you are actually building your investment thesis around that space, which you say is non-existent. Why? I'm not asking you a trade secret here,
Right,
because I believe why I'm trying to ask this question is because I believe an industry grows when there are more and more investors coming and looking at that space. So if you
right,
are inspired and motivated in that space,
right.
how would you motivate others to look at that?
So for me, it was a problem I saw, and being a founder, it was a problem I had to solve. It got so for me, the way that I function in a problem solving environment is, if I see a problem and it bugs me for way too long, I have to go and solve it. That's the only way that I function. So if it keeps on bugging me to the point that it's annoying, that why does that problem still exist? I don't see a solution for it out there. I just go out and solve it. So for me, the VC firm is just another startup that I'm working on that is going to help other startups.
And
But
how do you justify the risk associated with that, which other
so
VCs
yeah,
supposedly look at? I'm convinced with the market,
yeah,
believe me, and
yeah,
I'm sure, like you and I, probably there are 100 others who are right,
right.
but they are still not taking the plunge.
There's and I tell them not to. If they don't have value add to provide, and if they've never invested in hardware, don't. Right? Because all
Mhm.
you're going to do is you're probably going to invest on the hype. Your fund structure is probably not built to handle the exit timelines of hardware startups. So you will either end up getting out of it and writing it off on your portfolio, which if you write it off, the company suffers eventually, but you don't care, because your rest of your portfolio is doing great, and you this is just one hardware company out of 20 software companies that you invested in. So for you it's not going to be an issue, but for the founder it is going to be a big issue, because that will affect their later future rounds that they might have to do. So if you've never done it, don't go in on the hype.
So, am
uh,
I hearing that the is physical AI space is not for the generalist VCs?
it's not for the generalist. It's definitely not for the generalist, because what's going to end up happening is, even if you do go in because you think it's the hype is there, or it's a cool factor that you want to be on that cap table, at a certain point, if you don't bring value add, the founder is just you're going to be the low priority for them. They're not going to interact with you as much. They're just going to say, well, give us the money and get out of our way, because we have to figure this out on our own. So if you
Mhm.
don't have the value add to help those founders, it's better not to waste their time, right? So it's better to go in with the value add, and that's what angels provide early on. They can provide the value add on the product side majority of the time, but they can't keep up with it. It's unsustainable for them to keep up with it in later stages. On the business side, they can't do it for every single company that they're doing. So that's why the early stage VC is this important gap that has existed. The capital requires value add. If you don't have the value add, it is almost impossible to understand the sector properly, help the founder in any meaningful way, and or see the returns. A
Sure.
lot of angels see the returns and they're very happy with their portfolio, and they'll say hardware gave me the best returns ever, because they can stay in it for a long period of time.
Yeah, they
So
have patient capital. They have money.
they're
They don't
patient
have to give it
capital.
back to the LPs.
Yeah, exactly. So VC funds, if your fund is built for a 5-year exit timeline, it's not going to be possible. And you're investing in year 3, it's not going to be possible for you to exit in year 5. And
True.
you're not going to extend the life of your fund just for that one company. So you're just going to write it off. So it's just not built that way. So that's why it has to be built from the ground up. The funds have to be built from with the strategy in mind. You have to think, and there's a lot of funds that have been built, they got shut down with after one fund, because I don't know what happened. A lot of the times the value add was still missing from the hardware people. And I think people who understand hardware go into it as operators VCs, which is great. But the problem is, just one operator VC is not enough. You have to bring a whole community together. And that's what robotics has been doing for a long time. Because we didn't have all of this VC capital, majority of what we see in robotics, if you wanted to build a robot, the ROS ecosystem is open source, because there's so many developers just contributing to it, and that took a long time to get there. Without the VC capital, there's nobody controlling ROS. It's a totally open ecosystem, right? So, and now anybody can use that and build. If you wanted to, you could build autonomous robots right now with enough resources. You could do it in less than 3 months. If you wanted to build prototypes, you
Tell
could
me
do it in 3 months.
what are the emerging themes that you're watching, which are not there yet, but then, well, I think in today's age, how the AI has evolved, I would not probably say 10, 15, 20 years,
Yeah,
because what earlier used to happen in 20 years now happen in 5 or maybe 3 as
right,
well. So what do you
right.
see in next 3, 5 years in the space that we are talking about?
In the VC ecosystem or the
In in
found
in, in the physical AI, which is VC backable.
within that ecosystem, I see again there needs to be a mind shift with VCs. And if you realize this, anytime there's a fluctuating market and people are unsure about where to invest their money, they usually go for robotics. Like that's when robotics capital hits its peak. The moment
Interesting.
something goes wrong in software, people start investing in hardware because they know it's asset backed, and then they know that it'll eventually grow. So in the last 6 months, we've seen a lot of warehousing, where data warehouses investments come into play. And there's been a lot of thesis around that, because AI needs those data warehouses as well as cloud needs that data warehouses, and it's all hardware infrastructure, and a lot of people are investing in it. So the
Sure.
moment that happens, something goes wrong in the VC ecosystem, they turn to hardware, but they have no idea how to invest in hardware, right? The thing is, I think if you stick with it, if you build a strong thesis around it, if you add people who know the industry inside and out, if you add domain experts, if you add people who are going to have value add to those companies, then you can build an actual VC firm. Otherwise, it's very, I would say, stay away. It's still not for you.
Interesting.
If it's not, if it's, and to be clear, like I said, these founders listen to VCs who have the experience rather than to VCs then that don't have experience.
Agreed.
And because this is such a specialized space, founders have spent years and years getting into that space. I would compare them to a surgeon. They know what they are doing with their product, so they only listen to other surgeons. They're not going to listen to somebody else. So there's a
And
little bit
and
of an
and,
ego
and
involved there.
what are those specialities for those surgeons, aka the
The
evolving
robotics
themes in
people.
physical AI that you're watching?
So I look for qualities beyond the tech side. Within tech side, there's way too much to learn. I had I was lucky enough that I had a natural inclination to electronics, and I have a brain that can think in 3D. So mechanical side was pretty easy for me, and I'm good with my hands. So I only had to learn computer science and use it. But not everybody is multi talented in that way, where they're learning 3 sectors of engineering at the same point of time. Like they're not doing designing of 3D parts while they're also learning computer science. But if you have, that's amazing. If you as a computer scientist know what hardware you're going to deploy this on, and you can code depending on the memory limitations of that hardware, it's important to know that, right? Within robotics, it's very important. So those are skills you just need to know. You need to have a certain idea of a little bit of those things. Electronics people need to know the mechanical limitations of where are they going to install this in a robot. The mechanical people need to know the computer science piece of it and the electronics piece of it, just to know, okay, how much heat dissipation would be required for this particular part, and how to design in a way that it is both aesthetic and functional. So that's just the technical side of it. Then beyond that is the ability to learn, ability to listen to somebody else, ability to learn what your customer wants you to learn, not go in and say, this is what I'm going to build. If it's cool and it's what I'm going to build, but I don't care how the customer responds. So you have to listen to your customer at the end of the day. If you're not listening to your customers because you think it's cool, you're doing something wrong. So, and we've had founders who are very, very focused on the product and never ship it out because they're so confident in the product, and they're like, well, this will change the world, and not realizing the reality of the situation and saying, well, I should probably pivot, or I should try to find a different market or a different use case for this product if it's not seeing the adoption with customers that I wanted to see. So those are outside of that technical field. I think within the founding team, those characteristics are important. Might not be one
And
founder, but within the founding team.
and from the business point of view, what are the use cases in industries you will be watching closely being an investor?
Within robotics and IoT, I think is my main focus at the moment.
Any particular areas within that as well?
I'm excited about all of it. I don't limit myself to any particular like sector within that space. I'm excited about all of it. If you've got anything in agriculture, health, entertainment, hospitality, restaurant businesses, I don't care where the application is. I like all of them. But I think people are not ready for humanoids in homes yet. That has been I've seen that observation through, taking my robot dog on the streets of Toronto. People are like, oh, why do you have it? 80% of people are like, why do you have it? And what do you do with it? And then 20% of people are like, kill it. And I've had people stop on, street light and just say, stop their car, scream out the window, kill that dog. So people are not ready for it. Even those who are curious about why I have it, they usually don't see applications of it till I start mentioning the features. And I make it a point to mention features and let their mind go wild on what the applications could be. If it's a dog that has these features, and then they go, oh, can it be a guide dog? Can it actually go lift stuff for me? Can it, transport stuff from one place to another? Like, yeah, absolutely. I take it grocery shopping. I put a basket on top of it and put groceries in it, and I take it. It's a very expensive shopping cart, right? But I take it grocery shopping with me. So there's applications that I don't want people to assume, and that's why the AI piece is important, because people might use it in different ways. We don't know how they'll use it at the end of the day. So a lot of those
So what I'm
applications,
hearing is commercial and industrial mostly,
commercial,
domestic not
industrial,
yet.
100% industrial for sure. In controlled environment, 100% industrial, definitely an application for all of these things.
Maybe
In
defense, maybe agri,
Yeah,
anything which is commercial, but nothing
yeah,
domestic yet.
domestic in public spaces. I would say if you can install your robots in public spaces, people will start to see value in it. People will start to get comfortable with it, and at a certain point, they'll be ready for humanoids. Even humanoids are not ready for homes yet. We don't. If a humanoid glitches in a home environment, it's more chaotic. There's people roaming around. There could be kids, and there's a lot more breakable things in that environment. If it suddenly the arm goes sideways and behaves in mistakenly, goes from this end to this end, it could basically destroy your TV screen. So there's things that it can happen in the home environment that is just not ready for. The AI is just not ready there. The hardware piece is ready in that use cases. The
Yeah.
humanoids we can build easily, not an issue at all. The AI needs to learn, and they
And how far do you think are we from that?
I think it'll take a couple of years. We just need a lot of data, and the
And
way
is
to
that
gather
couple
that data is
five or is
public
that
environment.
couple 50?
Yeah. No, I would say by 2030. I mean, people are trying to aim by 2030. The reason for that is it just takes a while to get that data. You can use synthetic data, you can do all kinds of things, but at the end of the day, it has to function in the real world. And people have to be comfortable, because there's an uncanny valley psychology thing that also happens if people are not comfortable with it. Majority of the people who look at my dog in the video will usually say, why doesn't it have a head? Right? And people want a dog to have a head. It doesn't matter what the capabilities are. They want it to look like a dog, or have a tail. There's a lot of people who'd say that. So people just want it to feel natural. And we there's a lot of work that can be done on the hardware side, but also on the AI side. So it means people want it in the public space. You can install it in public spaces. You can have people interact with it. But for people to be comfortable with it, in their homes with their kids, in their private environments, it needs to be much safer. So there's an AI ethics involved there that
Yeah.
have to be taken into account.
We are talking about such a subject that we can probably, both you and I can go on for all
Absolutely.
day long, if not more.
I definitely can.
I would love to talk on that. But then I would say great thoughts, great insights for our introductory piece to the physical AI today. I think
Yeah,
you opened a lot of pieces which have been, I would say, gray for a while, both in the layman's perspective as well as the investment
mm,
perspective, which does put things in the context with this conversation today. And I really appreciate you taking time for us. I'm pretty sure
absolutely.
that there are so many other things that we want to talk about, and we will reconvene to
Absolutely.
talk about those. But I appreciate your time for all the thoughts that you have put together for us today.
Absolutely, we'll do a follow-up. I'll break down all like individual sectors. If we can, I can absolutely break down individual sectors. What happens in medical, what founders need to take care of, how VCs need to think about it. There's so much to do in each individual thing for VCs as well as founders,
Yeah.
that it's, like I said, it's a very vast domain. Physical AI is just an overarching umbrella of hardware and AI coming together.
Indeed.
So there's, you can go into the minutia. It takes a long time. I've luckily been tracking it for 20 years, so I can talk about it all day, every day. But there's perspectives that I think people don't realize when they invest in hardware companies, and VCs get disappointed that it didn't give them the returns. I say if you've never invested, stick to a safer side, right? Like stick to late stage stuff, stick to something you're comfortable with, stick to the software of our robotics. There's need for that as well. But if you want to invest in this space 100%, you have to go in with value add. That's the final closing thought on that.
Noted. So all those who are looking at this space to take a plunge into, and or probably are already doing, those who are already doing, I would assume that they would agree with what you just said. Those who are still watching it, take a note, bring the value add, and then look at the space. There's a big future that this industry has because of the reasons we discussed today, and many more outside of that as well. So having said that. Thank you so much again, Jasmeet. Until we get
Always a
together
pleasure.
again and discuss more about it, and perhaps maybe in person as well.
Absolutely. We're going to catch up in the valley soon, hopefully.
We will do that.
Awesome. This was a pleasure being here. I really enjoyed it. And it's always a pleasure talking to you. You know that.
Likewise.